as Vasu is going to speak about this today. Vasu is the CEO and Chief Architect at Right Data. And his topic today is going to be from governance to control plane, engineering trusted data products for the AI era. Very apt for this, shift in the paradigm with the AI that we are facing. So over to you, Vasu.
Thank you. Good afternoon, everyone. Can you all hear me okay? Yeah, firstly, I don't want to be, I'm kind of between you and your lunch. Try to make as interesting as possible, as informative as possible. Like Usha introduced, my name is Vasu Sattenapalli, the CEO and Chief Architect for Right Data. So I'm really excited to be here. It's a pleasure of me to actually be here. I flew from Atlanta just to actually meet you all. This is first time in Singapore. I'm really thrilled to see data practitioners in this side of the world. I live in US, I've been in the US for 25 years. And today's topic is very close to my heart. I want to start my conversation with asking one simple question. Can we trust the data? And this question might sound very simple, but for most of the organizations that I see, I don't know about you, this is a very difficult question to answer confidently. Do I trust my data or not? Collectively, if you look at different parts of the world, different companies, we have spent billions of dollars in modernizing data platforms, implemented lakehouses, cloud data platforms, governance practices. A lot has been gone into this, but this particular question is being asked very frequently despite all those investments that we've done. We're going to explore why, and then what should we do about it? That's a fundamental question that's been asked. And this question is being asked by, starting from executives to leaders of the business units. Do I really trust these numbers? That's a question that we always been asked. If you present a report, how do I know this number is right? Can I compare with something else? Right? That's a constant thing that we always hear. To cope with this, as data teams and data governance teams and data management teams, what we normally do is we try to reconcile data and establish some processes to reconcile the dashboards. Our data engineers and data scientists actually verifying the pipelines and double checking the pipelines to make sure my data pipelines are right and my data is reliable, etc. That's a continuous process that's happening. So what's really happening here? It's not a data infrastructure problem. It is a problem of how to operationalize trust. What are we talking about? Can I trust this data is not about the infrastructure and then all the investment that went in. How do we operationalize trust? That's basically where the fundamental issue is. If you look at this list, if you want to compare the problems that are happening and then all the infrastructure investment that went in, modern data stack is extremely powerful. So what are the things that we do in modern data stack? We have a cloud platforms, we have data governance initiatives, we also have a cloud lakehouses. A lot of things went in terms of modernizing the data and data stack. And also, we are getting into the era of AI. A lot of AI workloads are already running in production. So if you talk to somebody 3-4 years back, they say, I'm doing pilots, I'm doing POCs. But no longer that's the case. The AI workloads are running in production. People are actually trying to use AI to make the critical business decisions. That's where we are. And some companies are also evolving their architectures into data mesh, evolving their architectures into data fabric architectures. All this is great. So what is this telling? The infrastructure is actually clearly evolving. But the challenges are actually remaining the same. What are the challenges? Conflicting metrics. Because if you go to the meeting, team 1 comes and says my net revenue is this, and team 2 says my net revenue is this. There's a conflict in my metrics that I'm reporting. There's a data drift. And shadow logic. How many of you heard of shadow logic? What is shadow logic? Do anyone know what shadow logic means? Because in our enterprise data platforms, I may have a business logic that's embedded to compute some KPIs, but outside the data platform, people are doing their own thing. They basically dump the data and then doing their own calculations and coming up with their own metrics. That's a shadow logic which is outside our data platforms. That is another problem. And once we have the AI sitting on top of it, the inconsistency around the AI is also becoming a problem. And with all this is leading to the executives actually not being very confident, and maybe their adoption or actually their confidence levels are actually being low, if you will. So these are the problems that we're seeing. Why are all these problems happening? The one thing that I want to mention is infrastructure that we are upgrading do scale compute. It gives you a compute power. I can churn a lot of data. I can process a lot of data. It's actually giving you a compute. But what it is not giving is the trust. And how trust can be established in the data is not the data infrastructure that you're doing modernizing is going to give. What does? We'll look at that in a minute. This kind of a complex subject, whenever we actually try to explain complex subject, I try to take a metaphor. I try to take a metaphor by comparing a complex design that we're trying to explain, map it to something that we all understand. So for that, what I wanted to take, the example here, or the metaphor that I wanted to use is airports and air traffic control. This is probably the Singapore airport, I think, that's AI generated. So airports and air traffic control. So if you think about this analogy actually surprisingly matches bang on with our classic data infrastructure. How? Let's think about how airports works. What does airports has? Airports has runways. Airports has aircraft. And of course it has airlines. And it has weather tracking systems, but that's must have. And also it has rule books. There are certain rule books that airports has to obey. And last but not least, passengers. So if we think about these are the various components, if you want to try to draw parallels to the airport and various things that are happening in the airport and air traffic system to our enterprise data, in this case, runways are like data platforms. And aircrafts are like data products. I know we haven't introduced the concept of data product yet, but a lot of people have a different connotations to it. We'll talk about that. So runways are like data platforms, aircrafts are like data products, and airlines are like a business domains. A collection of data products belongs to a business domain. A group of aircraft belong to airlines, if you will. And of course, we have a weather pattern tracking system in air traffic analogy that maps to our schema drift and the data drift technologies that we have to constantly see how the data is changing and evolving, how to cope with it. And the rule books that we have in airport directly maps to the governance and policies that we write. Last but not least, the passengers, or the passengers in case of data infrastructure, the consumers. Typically, the consumers always has been analyst humans, but now it has changed. Besides the humans, there is also AI agents actually sitting on top of the data to consume it for whatever the purpose they are built for. So, in this whole thing, if you think about the infrastructure is there, but what is missing is the coordination. I just wanted to actually, I want to quiz somebody, raise your hand or just yell out. What is missing in this whole airport analogy, airport and air traffic analogy? What is missing? There is one critical thing that's missing. Without that, air flights cannot take off. What is it?
Control
tower. So for air traffic control tower is a must-have. Without that, you can have all this. But if there is no air traffic control tower, what happens? Without air traffic control tower, you may have runways, you may have flights taking off. All this can happen, but it can lead to near misses. It can lead to delays. It can also lead to communication breakdowns. Now, last but not least, very important thing, it can lead to safety risks as well. That's a reality in the airport airports and air traffic control world. If you draw the parallel back into our enterprise world, you can have all these various components and the programs in our data platforms. If you don't have a proper coordination among all these various aspects that we have, what would happen? It would basically cause metrics, conflicting metrics. It would cause data to be inconsistent, and there are some incidents around the data quality, and then hence the trust is going to erode. If the trust gets eroded, the adoption is going to be very low. And last but not least, now we are living in AI era. If you layer AI on top of the problems that we already have, it's going to amplify the problems than actually solving anything. So that's the analogy that I want to use. With all this said, don't get me wrong, governance is super critical. And in fact, like Usha introduced, our company, Right Data, is actually provides actionable governance and data quality for enterprises. I'm not lowering the importance of the governance, but it is important. But what else has to go along with the governance is what my fundamental thing that I want to cover here. Number one, what governance provides. There are policies that will define the intent, how I'm going to be using this data. That's a policies. And there is a stewardship that defines the ownership. You define stewards, and then it defines the ownership and then who is going to take care of that. And there are documentations that we write that defines the standards. All these are great. But unfortunate thing that the reality is policies don't enforce themselves. You can write policies, somebody or something has to actually enforce policies. And the frameworks that we're thinking of, which is stewardship and ownership, they don't automatically employ. There has to be some sort of an automation or engineering around it to make that happen. And documentations that we're writing, they don't report the issues by themselves. So these are the realities. So just like in airport scenario, you can have a rule books, but the rule books does not operate airlines. Rule books are an important aspect, but rule books itself does not operate airlines or airport rather. Now, here is where I want to actually introduce the idea of the data control plane. So now we talked about in an airline scenario, you have a control tower, the air traffic control tower. Just like that, even a data infrastructure, you need to have a data control plane. Okay, this, if you go Google it, if you read about it in Gartner, you will find the concepts. But I want to make sure we discuss this because this is a very timely subject. Data control plane is a mission critical success of AI. Why? Number one, what are the various things that are actually happening in the data control plane? So think of this data control plane as an operational layer that is actually linking the business intent with the technology platforms. Because you may have technology platforms that you implemented Databricks, Snowflakes, and all the lake houses. But if you want to link that to the data, like a business intent, this becomes an operational layer that actually connects these two. And if you want to double click into each one of it, there are various spheres around this control tower, starting from a data contracts to the observability to the data quality to the policies, all the way to trust signals. These are the various aspects that are necessary for our enterprise to take off and then operate safely. So, if you want to extend that metaphor that we just talked about, let's map it to our architecture. We just talked about the airport control system mapping to the enterprise data system, right? We have air traffic control, we map to what? Data control plane. Now, let's do a few more examples there. Within air traffic control, you have a radar system. What does the radar system do? It's going to find out which airlines is sitting where, and its traffic paths, etc. So similarly, in the space of data, there is a metadata observability concept that maps to radar system. Flight plans that we have, those are like a data contracts. And weather tracking systems are like a drift detection systems. And pilot communications are like a domain accountability. And the safety ratings that we have for each airlines, like trust scores for each of the domains. Because if I have all this data that I'm actually curating and then making it available to the business, you just like how you would have a safety ratings for an airlines for somebody to believe that yes, this is a safe airlines that I can fly. Even for my data also there has to be safety rating. That's a trust score. So these are the parallels, if you will. These are the things that are important to actually enable. There is one more shift that's actually happening. What is that shift? We all used to actually quite familiar with tables, and any kind of programs or reports or AI or anything that I do, we use tables. But now, think of it like, tables are more like a cargo, but aircraft is more like a data product. Okay? What is aircraft allowing you to do? Aircraft allowing you to do is fully consumable, it's safe to use. Fully consumable and safe. Just like that, for your data to be consumed, the data needs to have a safety and a reliability and quality, and it needs to be consumable. So raw tables are like a cargo, whereas data products are more like an aircraft, if you will. So now let's do a few more parallels here. Documentation. So for governance, the critical thing that we have is documentation. The documents are going to are more like static, right? I don't know how many of you actually work in a governance teams. We have a lot of policy documents that sits in SharePoint or somewhere, and they are not operational. The idea is to actually the concept of data products and bring all those SLAs, bring all those policies, attach it to the data, and make it like a data product. That becomes a contract. If someone is consuming, you know exactly what type of data that you're consuming, what's the SLA, what's the quality, who owns it, all that information is attached to it. And instead of actually having a reactive checks, you're going to have a continuous validation process in this concept. And last but not least, access provisioning. Someone wants the data, then I provide you access. But having an accountability, who is using it, why he or she is using it, how long they would need it, do they really need this data, is there a sensitive data that's involved? All these are the accountability aspects are going to go along with it when you transform yourself from raw data to data products. Okay, let's fast forward a bit. Now we talked about the typical airlines, right? A classic airlines. But now, 20 years from now we're introducing what? Autonomous aircrafts. And autonomous aircraft 20 years from now is more or less like AI agents now in our data world. What if I'm actually running autonomous aircraft without a radar system? What happens? It's going to make things worse. Same thing. If you try to run AI agents without having a data controls and a data control plane, it's like running autonomous aircraft without a radar. That's so we all know the impact of it, because if the minute what is AI is going to do? AI is going to actually make the autonomous decisions. It's going to take that data and then make autonomous decisions. And also it's going to make it much more faster. It does decisions at the machine learning speed, right? And it uses the context, it assumes the context it has is valid. So with all this, if any mistake happens on the foundations, my data is bad, my data is stale, if any of these issues would happen, AI is going to amplify those problems. So this is to reiterate the importance of having those foundations right with this data control plane as a concept. Now, let's come to our world, right? So far we talked about the analogies. This is architecture, this is the kind of architecture that we normally see every day, right? Any kind of architecture that you want to draw, you build layers, either horizontal swim lanes or a vertical swim lanes, right? So this is an architecture that we're quite familiar. At the bottom that you see the data platforms that we all familiar with. Data platforms like Snowflake, Databricks, or a SQL Server, an Azure, or a Teradata, doesn't matter. All these are the various data platforms that we have today already. If someone says, okay, and of course there are different layers, gold, silver, different layers within the data platforms. It has the source systems, all that is known. Let's look at upwards of data platforms. Today, if someone says, okay, I have data platforms, let's go build AI agents, the first thing that they do is they directly hit data platforms, hit the raw tables, hit the gold layer tables with the minimal or no context, with the minimal accountability, with minimal exposure to how good the quality is. They're going to directly bring those AI agents and connect to the data platforms. It worked fine in the traditional BI days when human is involved. Because when human is involved, when I'm a BI reporter, I'm writing a Power BI dashboard. I know exactly what is the intent, what is the context, and based on that I do my joins. But now we're talking about AI agents. We're leveraging AI. AI only reads data. AI requires context. Hence, directly connecting the consumption layer, which is on the top, down to the data platforms is not going to cut the deal. You definitely need these two layers in between. That's where the control plane and data products comes. All this data that we have in the data platforms needs to be cleanly organized into business domain based on the context, have an ownership, and then group them and create the data products. On top of data products, have this control plane which does the policy management, which does the quality as a code, and observability, trust signals, and the data contracts. These are the various foundation pillars that are must-have for AI agent programs to work. Because we all here excited about, okay, let's go implement AI agents. If you don't have those two fundamentals, it's going to be a doom. All the explanation that I just talked about, the analogy and the metaphor, of trying to do the autonomous aircraft without the radar system. If you don't have these two systems, your AI agents program or AI programs is going to most likely be going to fail. Because AI brings data. AI requires context. Now, that's about architecture. Now, this whole paradigm is also going to make a switch how organizations work. You know, in this group, I think there are a few people actually raise their hands. They're working in data governance. When we actually have a data governance, there is a data governance committees. We form a committee, and then we have certain meetings on a periodic basis. We do audit, right? And also we have some static documentation. We write policies, and last but not least, we also, if we find any problems, we go work with the data metadata teams and have some kind of a reactive fixes process that we have in case of a classic data governance era. Now in an agentic AI era, AI agents era, traditional data governance is not going to cut the deal. That traditional data governance has to morph into trust engineering. Trust engineering. What does it do? It is going to enable continuous validation. It's going to automate the guardrails, and it's going to measure the real reliability and the domain accountability ongoing basis. So these are the parameters, and this is the shift that's happening from an organizational construct perspective. And back in the days, governance teams, I also used to be part of the governance, are being seen as the gatekeepers. You're blocking the innovation. Why are you not letting me actually do what I'm supposed to do? And then that's why they try to take backdoors and download the data and do their own thing. That was the case. But by having this kind of transformative approach from a traditional governance to a trust engineering, governance will no longer be a gatekeeper, governance will become an innovation enabler. And which most of us, somewhere in one way or other, connected. Now, let's quickly talk about the control planes, and if we have a control plane, what does it do for us? It basically ensures the onboarding of domains are going to be much more faster, and it's going to reduce the friction towards the compliances, because you have a clear indication on where the compliance problems are. And we want to scale AI much safer with this approach. Okay, what I want to leave you all with is one part. One part that I want to leave you with is if you want to scale your infrastructure, great, it's going to scale your horsepower. But if you want to scale your confidence, or if you want to scale your trust on your data and confidence in the data, what you need is a control plane, data control plane. So data control plane is a concept that's a must-have for improving the confidence on the data. Without that, we are set to failure, especially in the AI era. That's one thing I want to give you all with. Thank you so much.